All right, so now your homework on composite functions, and let's practice together. So inside to outside. So first, arc cosine 4 over 5. That is not a point on my unit circle, so it's going to be a right triangle situation. So I'm going to draw a right triangle. Doesn't matter where you put theta. I'm just going to label it. So adjacent and hypotenuse. SOHCA TOA. Find this missing side. That's 3 using the Pythagorean theorem. A squared plus b squared equals c squared. You can go 25, take away 16 in your head. Square root of 9 is 3. You can do it. And then based on this triangle, what's cosine? And the answer is 4 over 5. Now, you could also understand this, that cosine and arc cosine undo each other, and the answer is 4 over 5. So, we'll go that and understand that. That tangent and inverse tangent undo each other. That sine and inverse sine undo each other. Now, the problem with this one is, inverse sine, that number is smaller than negative 1. That's too big a negative number. It has to be between negative 1 and 1. And if that number is too big or too small for that, it does not exist. Here, these undo each other, and the answer is pi over 3. These undo each other, and the answer is pi. I know this is too easy. There'll be a tricky one here. Here, this one, the problem is the angle is not in my domain restriction. So I have to find the angle. So this is in quadrant 4, 7 pi over 4. I have to rewrite it. And I need to find the angle that gives me the same answer, the same place on the unit circle, but within my domain restriction. So 7 pi over 4 is the same as negative pi over 4. So 7 pi over 4 would be in quadrant 4. The negative angle that's the same as, that gets me to the same point, is negative pi over 4. Then they undo each other, and the angle is negative pi over 4. Number 7, 5 pi over 6. So 5 pi over 6 is here in quadrant number 2. That is not in my domain. So I need to find the angle that is in my domain. So I go right across the circle to the 4th quadrant on the other side and go, what's the negative angle that would get me there, which is negative pi over 6. That's correctly in the domain restriction. Now arc, tan, and tan undo each other, and the answer is negative pi over 6. 3 pi over 2. Again, think of the unit circle. So that answer there for cosine 3 pi over 2 is 0. So I'm going to go across the circle to find the angle that is in my domain restriction. So I'm going to change that angle to pi over 2. That gives me the same answer. And arc, cosine, and cosine, they undo each other, and the answer is just pi over 2. Just make sure your angle is in the domain restriction. So negative pi, 5 pi over 3. So think, where is that located? So I have to go clockwise all the way around to find negative 5 pi over 3. That's right here. So what's the positive angle that would get me there? And that's your answer. So they undo each other, but what's the positive angle that's in my domain restriction? And the answer is pi over 3. Number 10. All right, so for this one, we have two different, so we can't just cross them out. This one we have to think a little. So what's the rule for sine? It's the y-coordinate. So the y-coordinate is root 3 over 2. If that's Batman, Robin, the partner must be 1/2. And using this point, what's cosine? And it's done. in the answer key, I was just looking at it, it's wrong because they put down the angle 2 pi over 3, which is not in the domain of arcsine. So that is the correct angle. So the angle would actually be pi over 3, and the answer would be 1/2. But I don't even need to know the angle, I just need to know the point for the composition. So what's the point that goes with root 2 over 2? So the x coordinate's root 2 over 2. That means the y must be root 2 over 2. That's Batman and Robin. And what angle is that point? Well, the angle doesn't matter. It just matters what tangent is using that point. So by definition, tangent's y divided by x. So y divided by x, and the answer is 1. 12. Now we flipped it around. So sine of negative 11 pi over 6. So I need to find what that value or where that point is on the unit circle. So negative 11 pi over 6. So that's all the way around, right? Going clockwise almost all the way around the full circle. So the quadrant we're in, and it's a 30-degree reference angle, is in quadrant number 1. So because I know it's a 30-degree reference angle, that's root 3 over 2 and 1/2. It's in quadrant 1, so both are positive. And what's the rule for cosine? I'm looking for the x coordinate, which is root 3 over 2. Oh, so they flipped this around on me. So inverse cosine means, you're right, it's root 3 over 2, but I'm finding the angle that goes with this. So what is that angle? And then you can write the angle as 30 degrees or pi over 6. What did I do? Flippity flip. I flippity flip this. So let me do it right now. So I was right. Sine is the y value right there. And the y value there is 1/2. Then, at what angle is cosine that? So now I got to flip it around and go, now it's the x coordinate, not the y coordinate. So that means this answer is actually 60 or pi over 3. Sorry about that. All right, I'll do better next. Here we go. 13. Be careful what I'm looking for. So inverse of root 3 over 3, and find the value of sine there. So I'm not looking for an angle at the end. So I don't even need to know the angle. You know what I could do? I could draw a right triangle in this situation. Even though it's special, I can go root 3 over 3, opposite over adjacent. I could find the missing side, which is 9 plus 3, which is the square root of 12. And then sine is opposite over hypotenuse. Now this does reduce down. So 3 over 12 is the same as 1/4, and the square root of 1 and the square root of 4, that full answer is 1/2. Because I'm not looking for the angle, I don't need it. I can just use this and find the values I needed. Here, my end answer is going to be an angle, so I need to remind myself of that. So what's the value of tangent at 3 pi over 4? So that's a 45-degree reference angle. We're in quadrant number 2. The rule is y divided by x. So at 45 we got root 2 over 2 and root 2 over 2. So when I divide, the answer is 1, but because we're in quadrant number 2, and understand that all students take calculus, that tangent in quadrant number 2 is negative, so the answer is -1. Now I start all this over again for this one. So what's the angle when cosine's -1? So now I ignore all this, and now I only focus on that. So the x coordinate's -1, which means the y coordinate must be 0. What angle goes with -1, 0 on the unit circle? So that's the answer is pi, or you could write down 180. Here we go. My end answer is not an angle, so I can just write a triangle. Now, I can't write a triangle with -1, so I do need to know the point on the unit circle and what angle we're at. So the point on the unit circle when it's -1 for tangent. Oh, I could do a triangle for this. What am I talking about? So I can definitely do a triangle for this. So it's 1 and 1, right? So I wasn't thinking it through. That you can know two sides, which means you know the hypotenuse. So understand from this triangle, what sine, and it's opposite over hypotenuse, or -√2/2. You could also understand that as a 45-degree angle, and sine at a 45-degree angle is √2/2 when we're in quadrant number 4. So it's negative. 16. So inverse cosine that's negative can only be in quadrant number 2. That's by rule, even if the answer key has a different thinking or understanding of that. It has to be in quadrant number 2. So what's the angle in quadrant number 2? That's -3/5. Well, I actually don't even need to know the angle, but I do need to know it's in quadrant number 2 to know if it's positive or negative. So I get the adjacent and the hypotenuse in quadrant number 2. The missing side using the Pythagorean theorem is 4, and then using this triangle, what's the answer for sine? And so the answer is 4/5. Let's try it again. Arctangent 3/2. It's positive, so I know we're in quadrant 1, so I know this answer is positive. So I can just draw a right triangle, understand it's opposite over adjacent. 9 plus 4 is the square root of 13. Then using this triangle, what's cosine? And it's 2/√13. And you could write that as 2√13/13. All right. There's your homework. Good job. Mr. G Math. Over now.